Hi children, welcome to today's DG class. Children, I am once again in front of you to explain the trigonometry of class 10th part 3. Children, in the earlier classes we have discussed about the trigonometric concepts, and today we are going to discuss about the last parts of the trigonometric concept, their applications in the problems. Shall we go? So, let us just have the solution for this. We have to draw a right triangle, so that we can understand that the trigonometry deals with the 90 degrees contained triangle, right. So, angle B is how much here? 90 degrees. So, we require A. Where is A? Here in the down. So, the base angles, there are two angles, that is angle A and angle B. So, we are going to discuss about angle A, sine A, and what the solution he gave us, cos A is equal to 12 by 13. So, with this I have to find out the other trigonometric ratios like sine A and tan A. Now, all of us know that ABC is a right triangle, right. So, if it is a right triangle, we know that Pythagoras theorem is applicable. So, by using Pythagoras theorem, how we have a chance to find the other ratios? Let us start, but before going to that, what is the ratio of cos A? That is adjacent side by hypotenuse. So, what is the adjacent side to A? That is AB, and hypotenuse here is AC. That means, I can say AB is 12 centimeters or 12 units, AC is equal to 13 units. So, when you know the base, when you know the hypotenuse, can you find out the opposite side, that is the other side? So, here what we have to do, please see, by using Pythagoras theorem, I can say that the square of the hypotenuse is equal to sum of the squares of other two sides, that is AC square is equal to AB square plus BC square. Now, what is AC value here? 13. So, I am writing here 13 square is equal to, in place of AB I write 12. So, 12 square, and BC we do not know. So, we are going to write as it is BC square. Now, 13 square is how much here? 169 is equal to 144 plus BC square. I need to find out BC square. So, I am bringing 144 from right side to left side. So, 169 minus 144 is equal to BC square, 25 is equal to BC square. That means, BC is equal to root of 25, that is how much? 5. So, we got the value for the BC. BC is how much here? 5. When I say BC is equal to 5, what is the formula to find the sine? Sine A, that is equal to opposite side of side opposite to the angle A is, what is that one? That is BC, hypotenuse as usual AC. So, answer is BC by AC. Just now we got what is the value of BC? 5. So, 5 by 13 is the sine A value, is it right? Now, tan. What is the ratio of tan? That is opposite by adjacent side, is it right? Now, what is opposite here? BC, and adjacent is AB. So, your answer is going to become 5 by 12. Are you clear, children? Observe that when one particular ratio has been given, by using the triangle and Pythagoras theorem concept, we are able to find out the remaining ratios also, is it right? Now, do we have any alternate method without using the triangle? Yeah, we have the method that is called as the identities method. That means, by using identities also we can find out the other ratios. Let us see, that is called as alternate method. Alternative method for using identities. So, already we know that cos A is equal to how much here? 12 by 13. Now, we have a formula, cos square A plus sin square A is equal to 1. This is an trigonometric identity. With this, I can say now sin square A is equal to 1 minus cos square A, but we know cos A is equal to how much here? 12 by 13. That means, I will write sin square A is equal to 1 minus 12 by 13 whole square. This is going to become 1 minus 144 by 169. So, if I take LCM, I will be getting here 169. So, you will be getting the numerator as 169 minus 144. After subtraction, of 144 from 169, you are getting 25. So, it is going to be a 25 by 169 the ratio, right. Now, this is sine square A. What about sine A? Let us see. Therefore, sine A is equal to under root of 25 by 169. Sorry, sine A is equal to under root of 25 by 169, which is equal to 5 by 13. So, by this we are able to identify that by using the identities we have found the other ratios also. Please see. Now, with this how to find out the tan condition? We know cos A is equal to 12 by 13, sin A is equal to 5 by 13. Now, we have a tan condition sin A by cos A, that is equal to how much here? 5 by 13 by 12 by 13. So, if I cancel 13, what I am going to get here? 5 by 12. That means, tan A value is equal to 5 by 13. So, in this way we are able to find out the answers for the given questions by alternative methods by using different concepts, right. Children, in the earlier we have discussed about the problem based on the trigonometric identities as well as the trigonometric or triangle, right triangle we have discussed. No? So, now we are going to discuss one more example. Please have a look here. Now, the question is evaluate sin 30 degrees plus tan 45 degrees minus cosec 60 degrees by cot 45 degrees plus cos 60 degrees minus sec 30 degrees, right. The solution for this sin 30 degrees plus tan 45 degrees minus cosec 60 degrees by cot 45 degrees plus cos 60 degrees minus sec 30 degrees we have. So, we have to substitute those values in the problem wherever we require. So, what is sin 30 degrees? So, in the rough we have sin 30 degrees is equal to 1 by 2. That means, I am going to write here half, that is 1 by 2. Tan 45 degrees is how much? 1. So, I am going to write here 1. Tan cosec 60 degrees is how much here? 2 by root 3. So, I am going to get minus 2 by root 3 here. Next, what do you have here? Cot 45 degrees is equal to how much? 1. Similarly, cos 60 degrees is how much here? 1 by 2 plus half. Cosec 30 degrees 2 by root 3. So, minus 2 by root 3. If you see that numerator and as denominator, almost all the values are same, but half and the 1 are in different places. If I shuffle them, what happens? Let me see. You see that both numerator as well as denominator are exactly the same. So, what I can do here? Here I have a chance to cancel both numerator and denominator on the whole. That means, please see. So, when I cancel the numerator and denominator on the whole, I will be getting the answer as 1. So, the ultimate answer is 1 here. So, for you we have one more example. Example 3, evaluate sin 60 degrees into cos 30 degrees plus sin 30 degrees into cos 60 degrees. What is the value of sin 60 degrees plus 30 degrees? That means, sum of that 60 plus 30. Here he is asking us to give your answer. That means, what can you conclude with this? Let us see the first case and second case solution. Sin 60 degrees into cos 30 degrees plus sin 30 degrees into cos 60 degrees. We are going to write those values here. Please see. Sin 60 is how much? Root 3 by 2. So, I am going to write root 3 by 2. Cos 30 is root 3 by 2. So, again into root 3 by 2 plus sin 30 is how much? 1 by 2. So, I am going to write here 1 by 2. Cos 60 1 by 2 into 1 by 2. Now, you are able to see root 3 in by 2 into root 3 by 2 plus 1 by 2 into 1 by 2. If you multiply them, what you will get here? 3 by 4 plus 1 by 4. If you go for the LCM and add them, what you will get? The LCM is 4, the numerator becomes 3 plus 4, that is called how much here? 4 by 4, which is called how much here? 1 is the answer for you. This is the sin 60 degrees into cos 30 degrees plus sin 30 degrees into cos 60 degrees. Now, let us see what is the value of sin 60 degrees plus 30 degrees. Sin 60 plus 30 is equal to how much? I can write it as sin 90 degrees, whereas sin 90 degrees how much? 1. So, with this you are able to see that the answers what you got in the previous case, the answer what you got in the now, both are same. So, with this what we can conclude? Sin 60 degrees plus 30 degrees can be written as sin 60 into cos 30 plus sin 30 into cos 60. So, this is like a formula we have, that is sin A plus B is equal to sin A cos b plus sin b cos a. Please see, we have one more example for you. Show that tan 48 degrees into tan 16 degrees into tan 42 degrees into tan 74 degrees is equal to 1. He is asking us to show it as 1. Here we are going to use the concept of complementary angle concept. All of us know that sum of any two angles is how much? If it is 90 degrees, you will be calling them as complementary angles. So, here we are going to use this concept complementary angles in this particular sum. Solution for this, first I will write LHS tan 48 degrees into tan 16 degrees, tan 42 degrees, tan 74 degrees. Now, I can say that 42 degrees can be written as 90 degrees minus 48, and similarly 74 I can write it as 90 degrees minus 16 degrees. That means, tan 42 I can write it as 90 minus 48, tan 74 I can write as 90 minus 16. Please see. So, tan 48 degrees into tan 16 degrees. Now, tan 42 became tan 90 minus 48 degrees and tan 74 became tan 90 minus 16 degrees. Now, please see, we have a formula tan 90 minus theta, it is nothing but cot theta, is it right? So, now I am going to write here tan 48 degrees into tan 16 degrees into what happened? It became cot 48 into cot 16 degrees. But we know that cot is equal to how much? 1 by tan. So, I will replace this cot 48 and cot 16 by using tans. How I write? See, tan 48 into tan 16 degrees into cot 48 I wrote it as 1 by tan 48 degrees into, similarly cot 16 I wrote it as 1 by tan 16 degrees. Is there any chance for cancellation here? Yes, I can cancel tan 48 degrees up and down, that means both in the numerator and in the denominator of the. Similarly, I can cancel tan 16 degrees also. So, what you left with? The answer is 1, that is nothing but RHS. So, what you can say, LHS is equal to RHS, hence proved. So, with this we will continue with one more example, children. Example 5. If A, B and C are interior angles of a triangle ABC, then show that sine A plus B by 2 is equal to cos A by 2. Sin A plus B by 2 is equal to cos A by 2, he is asking us to show. Now, what do we have a condition by the properties of the triangle, that is angle sum of the triangle. What you can say now, sum of the angles of it, interior angles of a triangle is 180 degrees. So, A plus B plus C is equal to how much? 180 degrees. So, what do you call this? Angle sum property of triangle. Now, if I take A from left to right, what do you get? B plus C is equal to 180 degrees minus A. I will divide both left side and right hand side by 2. I have a chance to separate them. What I will get here? 180 by 2, it becomes 90. So, that means B plus C by 2 can be written as 90 degrees minus A by 2. Now, apply sine for both the sides. Sine of B plus C by 2 is equal to sine of 90 degrees minus A by 2. But we have a formula, sin 90 minus theta is equal to cos theta. That means, what you can say now here. So, 90 minus A by 2 can be written as cos A by 2. That means, what you can say, sin B plus C by 2 is equal to cos A by 2. With this we have proved that left hand side is equal to right hand side, that is hence proved. Now, we will move to one more example. If cos 7A is equal to sin A minus 6 degrees, where 7A is an acute angle, find the value of A. Solution for this. Cos 7A is equal to sin A minus 6 degrees. Here we are able to see one is the cos and other one is sin. So, we have to convert both either into cos or sin. Cos theta is equal to sin 90 minus theta. So, can I write this cos 7A as sin of 90 minus 7A? On the other side we have same sin A minus 6. Now, when both are sin, I can equate those angles and I can say 90 minus 7A, that is 90 degrees minus 7A is equal to A minus 6 degrees. Now, I have opened the brackets, reshuffling them. I brought the numbers on one side and are all A's to other side. So, what I have got? 90 plus 6 is equal to A plus 7A. 96 is equal to 8A. Now, I have to reshuffle it. 8a is equal to 96 degrees, where a is equal to 96 by 8, that is how much you got? A value is equal to 12 degrees. So, with this we have found that how much is the value of a. So, now we have one more example for you. Evaluate sine 5 degrees into cos 85 degrees plus cos 5 degrees into sine 85 degrees. Already we did this kind of sum in the previous way, right. So, here what we have to do? Let us go with the concept of the two things. One is complementary angle, other one is, that is, we have to use the identities also. Suppose if I convert cos into sine and a sine into cos, what type of formula we get? Let us see here, please. Solution for this: sine 5 degrees into cos 85 degrees plus cos 5 degrees into sine 85 degrees. I will convert 85 as 90 minus 5. So, I will be getting here sine 5 into cos 90 minus 5 degrees plus cos 5 into sine 90 minus 5 degrees. So, this becomes where we have a chance to convert into sine to cos, cos to sine. Cos 90 minus theta is equal to sine theta. Similarly, sine 90 minus theta is equal to cos theta. So, I am going to get the answer as sine 5 into sine 5 degrees plus cos 5 degrees into cos 5 degrees. So, this is going to become sine square 5 degrees plus cos square 5 degrees. This is looking like a identity of trigonometry. What is? Sine square theta plus cos square theta is equal to 1. So, with this what you can say? The answer is 1 here. Are you clear, children? So, we have solved this problem by with a two different formulae, and we have applied two different concepts, that is complementary as well as the identity formulas. Now, shall we go to one more example, please see? Show that under root of 1 plus sine a by 1 minus sine a is equal to sec a plus tan a. So, let me go with the solution. So, I will write first LHS. LHS is equal to 1 plus sine a by 1 minus sine a. Now, why I need to extend this? Children, here I am going to apply a concept called as the rationalization. In previous class, you have learned how to rationalize the irrational numbers, is it right? So, now we are going to use the same concept, and that concept is called as multiplying both numerator and denominator with the conjugate. Please see what I am going to do. I am going to multiply inside the square root, that is 1 plus sine a in the numerator as well as 1 plus sine a in the denominator. So, that I will be getting the answer as under root of 1 plus sine a whole square in the numerator, and the denominator it is like a plus minus b into a plus b, it is like a square minus b square. So, I am getting here 1 minus sine square a. So, now we have a formula. So, that what I have to do, please, 1 plus sine a whole square by, please see, I am going to use the identities where cos square theta is equal to 1 minus sine square theta. That means, in place of 1 minus sine square a, I write cos square a. Numerator as well as denominator with under roots, under root of 1 plus sine a whole square by under root of cos square a. So, if you are removing the roots and squares, what you cancellations, what you get? 1 plus sine a by cos a. I will separate them, 1 by cos a plus sine a by cos a, where 1 by cos a can be written as sec a, right, and sine a by cos a can be written as tan a. So, I am getting here the answer as sec a plus tan a. So, LHS equal to RHS, hence proved. So, now we have the one more example for you. So, let us see that how it is going to be solved here. Prove that sin a plus cosec a whole square plus cos a plus sec a whole square, which is on the left side, which is equal to 7 plus tan square a plus cot square a. So, what we have to do? Let me take LHS. Left hand side is sin a plus cosec a whole square plus cos a plus sec a whole square we have. So, when I continue with this, either I am going to expand it both the squares. If I expand them, what happens? You please see, I am getting here an answer as sin square a plus 2 into sin a into cosec a plus cosec square a. That is the first part. Second part in this, cos square a plus 2 cos a into sec a plus sec square a. Now, we know that cosec a is 1 by sin a. So, that means sin a into cosec a, similarly cos a into sec a will become 1. So, please what happens we will see, sin square a plus 2 into sin a into 1 by sin a plus cosec square a that is the first part. In the second part, cos square a plus 2 cos a into 1 by cos a plus sec square a. So, I will be able to cancel them. So, 1 into 2 is 2. Next step what we have is, that is sin square a plus 2 plus cosec square a plus cos square a plus 2 plus sec square a. This is going to result you like this: sin square a, when you open the bracket, sin square a plus 2 plus cosec square a plus cos square a plus 2 plus sec square a. So, we will be continuing. What happens here, please see. I am going to shuffle them. I brought all the numbers to one side and sin square a and cos square 2 together and cosec square a plus sec square at one particular set. Now, 2 plus 2 becomes 4, but let me keep as it is. We know that cosec square theta is equal to cot square theta plus 1, but can I write cosec square theta as 1 plus cot square theta? Right. Similarly, sec square theta minus tan square theta is equal to 1. So, I will change it into sec square theta is equal to 1 plus tan square theta. That means, wherever cosec square a is there, I will write it as 1 plus cot square a. Wherever sec square a is there, I will write it as 1 plus tan square a. So, I am getting here answer 2 plus sin square a plus cos square a plus 1 plus cot square a plus 1 plus tan square a. Now, we already know that sin square a plus cos square a can be written as 1 because by basing on the identities. So, that is the reason I have grouped it. 2 plus in the bracket sin square a plus cos square a plus 1 plus cot square a tan square a we have. Sin square theta plus cos square theta is equal to 1. So, I am going to write it as 2 plus 1 plus cot square a plus 1 plus tan square a. I take all the numbers to the one particular place. So, what you are going to get here now? 7 plus cot square a plus tan square a. If I shuffle it, 7 plus tan square a plus cot square a we are going to get. That means, here left hand side we are able to prove it as a equal to right hand side. That means, LHS is equal to RHS, hence proved. So, one more example for you. If sec theta plus tan theta is equal to p, then what is the value of sec theta minus tan theta? It looks a little bit complicated, but still it is, we will be able to do it very easily. Please see here the solution, you please see, we have a rule: sec square theta minus tan square theta is equal to 1. This is trigonometric identity. A plus b into a minus b, we are going to get a square minus b square. Similarly, in a reverse way, a square minus b square can be written as a plus b into a minus b. So, we have a form, see, a square minus b square is equal to a plus b into a minus b. Now, I will write sec square theta minus tan square theta in the same form. Sec theta minus tan theta into sec theta plus tan theta is equal to 1, but sec theta plus tan theta is equal to p as per the question we have. So, I will write here sec theta minus tan theta into p is equal to 1. Therefore, sec theta minus tan theta is equal to 1 by p. Are you clear, children? So, very easily we have got the answer for this. So, we have one more example for you. Let us check here. See, if cosec theta plus cot theta is equal to k, then prove that cos theta is equal to k square minus 1 by k square plus 1. How to prove this? Solution. This is a little bit lengthy. Here we have to be very careful that we have to mention equation 1, 2 like that, and we have to understand like a algebraic way of addition and subtraction of the equations we have to see. So, we have to adopt the algebraic concepts also while solving this particular sum. Children, let us continue. Cosec theta plus cot theta is equal to k. Let me call this one as equation 1. We have a trigonometric identity: cosec square theta minus cot square theta is equal to 1. Same concept what I have used in the previous, same thing I am going to use here also. A square minus b square is equal to a plus b into a minus b. Same, cosec theta minus cot theta into cosec theta plus cot theta is equal to 1. By equation 1, we have that cosec theta plus cot theta is equal to k. So, I will write here cosec theta minus cot theta into k is equal to 1. Therefore, cosec theta minus cot theta is equal to 1 by k. So, let me call this one as equation 2. We have equation 1 and equation 2. I am going to use these two equations and I am going to solve them by algebraic form. So, let me add equation 1 and equation 2. By adding equation 1 and 2, what we get, please see. Cosec theta plus cot theta is equal to k, cosec theta minus cot theta is equal to 1 by k. When I add, we know that cot theta and minus cot theta gets cancelled, you will be getting here 2 cosec theta is equal to, on the right hand side, k plus 1 by k. So, if you solve it, what you will get? 2 cosec theta is equal to k square plus 1 by k, because you are taking LCM here, is not it? Now, cosec theta is equal to k square plus 1 by 2 k. So, let me call this as, now cosec means 1 by sine. So, I am going to convert into sine. So, 1 by sine theta is equal to k square plus 1 by 2 k. Therefore, sine theta is equal to 2 k by k square plus 1. So, I will be calling this one as equation 3. Are you clear, children? So, now we will be getting on to the one more system, that is, we have did the addition of the equation 1 and equation 2. Now, I am going to subtract equation 2 from equation 1. What I will get here, please see. Cosec theta plus cot theta is equal to k. The second equation is cosec theta minus cot theta is equal to 1 by k. I want to subtract. The signs of the second equation will always change, plus becomes minus, minus becomes plus. See. So, now cosec theta minus cosec theta both gets cancelled, you will be getting the answer as 2 cot theta is equal to k minus 1 by k. After LCM, 2 cot theta is equal to k square minus 1 by k, cot theta is equal to k square minus 1 by 2 k, but cot theta means what? Cos by sine, is it right? So, cos theta by sine theta, I am getting k square minus 1 by 2 k. Now, I will be continuing. So, what I can say now? Cos theta is equal to k square minus 1 by 2 k into sine theta. But in the earlier equation 3, it shows that sine theta is having some value. So, I will substitute that value here now. By equation 3, what I will get here? Cos theta is equal to k square minus 1 by 2 k into 2 k by k square plus 1. So, 2 k's cancel. I will be getting here the 2 k and 2 k got cancelled. So, cos theta is equal to k square minus 1 by k square plus 1. Are you clear, children? So, I hope that you have understood this. So, with this what you can say, hence proved, that is, we have proved that cos theta is equal to k square minus 1 by k square plus. What we have discussed are clear to you, and I expect you will be going through still more examples from your textbook and other referential textbooks what you have on the based on the trigonometry, and you will be solving them based on the identities or trigonometric ratios what have been explained to you. So, here is a small assignment for you, please children. Assignment 3, evaluate sec 35 degrees by cosec 55 degrees, express sin 81 degrees plus tan 81 degrees in terms of trigonometric ratios on angles between 0 degrees and 45 degrees. That means, you have to show them between 0 and 45 degrees. Question number 3, simplify 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta. Question number 4, evaluate 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. Question number 5, can the value of sin theta is equal to 4 by 3? Justify. Are you clear, children? Children, I hope you have understood how to solve the assignment questions. All the questions are for you in a better manner. I hope that you will be able to solve them very easily. If any problem is there, if you have doubts, you can consult your subject teachers and you can